Creativity. It's at the heart of who we humans are. With brains equipped by evolution to invent, to write, to make art and music. We humans are special, right? But wait. What if a robot could paint a masterpiece? What if artificial intelligence could compose great music? Does a robot, a machine with artificial intelligence, driven by code and algorithms, feel and express itself uniquely and originally?
You are just a machine, an imitation of life. Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
Over some 40,000 years, human creativity has exploded, from drawings on cave walls through the great art of centuries to come, to ever more advanced technology and design. Now, scientists and artists are asking, can a robot truly imagine an original masterwork? Or can it only copy the patterns of a human painter or musician? Does this computer version of Vivaldi sound like the real thing? Can artificial intelligence feel emotion and turn it into art? Do algorithms with yes-no options have the potential for unlimited creativity? Even the human brain, with its 86 billion neurons, may have creative limits. Computational creativity is leading us to ask new questions about human creativity. Is this essential human trait truly unique? How far can it take us? Will artificial intelligence be a competitor? Or can it be a collaborator, helping us towards still unimagined creations? Hello, and welcome to Computational Creativity. My first guest is a member of Google Brain's Magenta team. He is currently working on neural network models of sound and music, and recently produced a synthesizer that designs its own sounds. He's also a jazz guitarist. Please welcome Jesse Engel. Also with us is an assistant professor at the University of Illinois at Urbana-Champaign in the Department of Electrical and Computer Engineering. He focuses on several surprising creative domains, including the culinary arts and fashion and the theoretical foundations of creativity. Please welcome Lav Varshny. Also with us is an associate professor of psychological and brain sciences at Dartmouth College. He is interested in the neural basis of imagination and in the evolution of human creativity. Please welcome Peter C. And finally, an artist in residence at Bell Labs, exploring new forms of drawing with virtual reality, biometrics, machine learning, and robotics, a former research fellow at MIT's Media Lab and artist in residence at Google. Please welcome Sugwen Chung. Peter, it seems like there are many possible pros and cons for approaching computational creativity. One potential con would be we don't even fully understand human creativity yet. I mean, as someone who has studied the evolution of human creativity, where does it come from? What do we know about it? What don't we know about it?
Mammals that have descended from a very long lineage, and in the hominin lineage, we diverged from chimpanzees something like 7 million years ago, or no, from the common ancestor with chimpanzees and bonobos about 7 million years ago. And we went through a long period of having small brains. We were bipedal. The Australopithecines, which you can see in the lower left there, and in the lower middle. But then around 2.2 million years ago, Homo habilis created stone tools. And these old devise stone tools were very simple, basically just broken rocks. But then about 1.8 million years ago, 2.0 million years ago, Homo erectus in the upper middle there created a kind of hand axe called the Acheulean hand axe, which hardly changed for 1.5 million years. So what's really striking is how uninnovative Homo erectus was. And yeah, no.
He had one good idea and he stuck with it.
Yeah, maybe it was and then, the Heidelbergensis, which is in the upper right there, is about 600, 800,000 years ago. Again, very non-innovative. And even the Neanderthals, who had this so-called Mousterian tool set, it hardly changed for over 150,000 years. And then our species shows up. And in the case of Europe, kind of in the middle of Europe, probably they came up the Danube and couldn't go any further and their artifacts are incredible, right? You see the first evidence of instruments, of art, and we can't know for sure how this came about because thoughts don't leave fossils, neural circuits don't leave fossils. All we have are bones and skulls and artifacts. But the artifacts that show up are just incredible, right? Bone flutes and beautiful art. So something happened in our neural circuitry that afforded us the capacity to think of such things and then paint them or create them. And some of them involve the creation of objects that existed in their world, like that bison up there. But some of them involve the creation of objects that could not exist. And near Ulm, in what is now Germany, there's a cave where they found this Löwenmensch, this lion-headed human. So there was never a lion-headed human. So somebody had to imagine that 35 to 40,000 years ago and then go and build it. So I'm very interested in the neural circuitry that could have created that.
So just to be clear, this is not a result of some kind of physical evolution. The brain pan we don't see an increase in size of the brain in the species.
No, we do see an increase in the size of the brain from roughly the size of a chimpanzee, 350 cubic centimeters, up through Homo habilis, getting up to maybe 600 cc. Homo erectus gets bigger and bigger. And the Neanderthals actually had brains that were bigger than ours. Much bigger, well, not much bigger, maybe 1450 cc, whereas ours is about 1300. And yet Neanderthals with their bigger brains were not very innovative. Their tools hardly changed. But what really seems to change in our skulls and in our brains, because the skull molds to fit the brain, is this. Our foreheads got really big. So something about our frontal cortex changed. And I suspect this was very central to our becoming more creative.
So when did this happen? I mean, Homo sapiens as a species was around for a while, and it seems like what you're saying, it sort of describes a J-curve, where there's a sudden explosion of innovation.
It's a big puzzle, right? So I can look at a skull from 130,000 years ago, and it looks more or less like a modern skull. But the first evidence of sort of jewelry and art is maybe 70, maybe 80,000 years ago in South Africa in the Blombos cave. And in Europe, Cro-Magnon man, our species, shows up about 41,000 years ago, give or take a couple thousand years. And it really seemed to be a big bang, a cultural big bang. And what that was, I think nobody knows. Was it a change in culture, a change in language? Nobody knows.
But Lav, you've studied some of the theoretical foundations of creativity. Mm-hmm. It is important to at least ask these questions, because if we're going to talk about computational creativity, we need to know what we're starting from.
Exactly. And so what I've been working on is a mathematical theory of creativity, which again seems perhaps strange, right? How can you mathematize something like creativity? And the way I've been defining it is we want things that are both novel as well as high quality in the domain. So if we're thinking about food, we want it to be flavorful, or if we want fashion, we want it to be visually appealing, perhaps. But novelty seems to be fairly consistent across domains. Things that change your beliefs are perhaps the most surprising and the most novel.
The human brain, as neuroscientists know, it has very finely balanced between the need for knowing what's coming next, expectation, the satisfaction the brain gets when it knows the next digit in the sequence or the next word in the sentence, versus novelty. And whether you can mathematically determine that sweet spot is still kind of an open question, I would imagine.
It is, yeah. How to balance novelty against familiarity. That's really the question that artists face. You don't want to deviate too much, perhaps, because then it's not understandable, but you definitely want to push the envelope.
So with food, I mean, does the computer put together things that no human chef would ever dream of putting together, like,
yeah, like
I don't know, blueberries and pork and...
Yeah, you can definitely come up with novel combinations that have never been done before. So things like cocoa powder, saffron, and almonds, for example. That's incredibly good, but no one had ever done that.
You've also been working with an algorithm that, if we're going to talk about artificial intelligence learning, there are the different algorithms that enable it to do that. So before we get to Jesse and his musical tools, talk us through this algorithm that helps to learn a machine to learn to create music.
Right. So what we wanted to do is essentially learn what are the laws of music theory, what are the principles of good music, as it were. So what this algorithm is doing is it has two parts. Essentially a teacher that knows Bach and a student who's trying to learn what is music. And they iterate between each other. So we want to build this hierarchy of concepts in music. And further, we want them to be human interpretable. And so that's roughly what this algorithm tries to do. And then eventually we can use those principles then to inform composition, the generative question of creativity.
So is there an analogy to how we, as humans, would learn the theory of making music?
Yeah, in fact, the rules that the algorithm generates are exactly or nearly the ones that are taught in music theory courses. They go step by step in roughly the same way. Though there are a couple rules that come out that some of our colleagues in colleges of music find kind of interesting as well, things that they hadn't noticed.
Now, Jesse, in the field of music, we have seen some attempts made at quote-unquote generated music. Brian Eno, for example, in England, has been pursuing this for years. What is the attraction in taking something that seems to be so inherently human and trying to expand that into the world of artificial intelligence?
That's a great question. So I think it's interesting to think of things in the context that creativity and tools have always been co-evolving, right? We weren't able to, the evolution of well-tempered instruments allowed for, playing in multiple keys, and algorithms and machine learning, artificial intelligence are just sort of the next step in this process where they're creating new opportunities to interact with composition, new interactivities, new ways to interact with sonic texture, and just new tools to express ourselves creatively.
What are you and the Magenta team at Google, what is your kind of approach to the music creativity process?
What's interesting about machine learning and what's called AI is that it's really a data-driven way, or at least a lot of the current methods are a data-driven way of discovering some of these core components to a given set of data, whether it be audio from someone talking, or the core components of a recipe or anything like that. And so once you've identified these core components, then you can start playing games about how do we mix and match them? The systems aren't perfect. They fail in interesting ways because they're trying to do the best they can, and they're trying to do according to the data that we show them. And the data we show them comes from the natural world. So the mistakes they make are somewhat in line with the natural world, and so they have a kind of more humanistic character to them, which is actually a great source of, it's a different type of creativity. This is creativity through trial and error, or mistakes.
Well, that sounds very human. I mean,
Right.
Jamaican musicians in the early 60s listening to offshore radio from the Southern American states and thinking, oh, I got to do me some of that R&B stuff and getting it wrong and creating reggae. I mean, this is how almost every kind of development in our arts has happened.
Or like in the case of the 808 drum machine, was originally invented to be a perfectly accurate drummer. It was supposed to be a replacement of a drummer, but it wasn't. It sounds like a drum in a box, But it actually, the way that it was not perfect, the kick drum and stuff, was actually, the starting point for a lot of electronic music and hip hop, and so there's the way that you have your creative intention, and then it goes a little bit off. But if you're guiding your creative intention, if it's grounded in the world, it can be a great creative source as well.
With these machines, is the learning experiential? Can it be experiential, or is it completely based on what we, the people, have taught it?
No, I definitely think it can be experiential. The standard way of teaching things is to give it a bunch of exemplars, and then it has to try to, it meaning the algorithm that you come up with, has to try to determine some structure within that. But there's an alternative way where you give a bunch of core components, and an algorithm can try to combine these components in different ways. And there's evolutionary algorithms, which sort of like you sort of take these two things and you say like, well, what if I combine them? I would have a child of them. And there's also reinforcement learning, where you sort of give it feedback. If it combined two things in a good way, then you say, okay, good job, and it does more things like that. And those are some of the frontiers of these types of algorithms.
All right, now, at the table there, you have a kind of melody generating system that puts this theory into practice, right?
Yeah, so the Google Magenta project, it's part of a machine learning research group. So we do fundamental research, but one of the key things that I think often gets overlooked is there's always a human in the creative process. And so it's an open source project that we try to get as much engagement from creative coders and artists in the community. And we try to create tools that allow these artists to interact with these algorithms and without having to, do a bunch of programming on the command line and that type of stuff. So I just brought along a few of them here to show.
Well, why don't you, demonstrate
Sure.
what this thing can do? Sugwen, while Jesse's walking over to the table, does this sound analogous to your sort of collaboration?
I started a robotic drawing collaboration a few years ago with the intent of exploring how we could measure creativity and actually reflect that back as a type of performance. So I think as I've come to work with the robotic arm and with these new machine learning algorithms, I've come to view it as more of a collaborator because of its ability to reflect our own creative processes. And I think that's a new process that's only going to grow more in the future.
What are we looking at here?
So this is my project, Drawing Operations Unit Generation 1. It's sort of a first very initial foray into what it would be like to collaborate with a robotic agent. The first generation is really simple. I wanted to show a few things. I wanted to show sort of a human hand and a robotic arm working in harmony, because I feel like that image is really, and that narrative is underserved in our culture now. And also think about how relationally and how behaviorally the sort of two organic and robotic units could work together to create something beautiful or not, and kind of explore that site of ambiguity.
And Jesse was talking about, I think you were saying that, for you, getting the feedback from the machine, affects your creative process.
Absolutely.
So it becomes a feedback loop.
Absolutely.
Yeah.
You did bring one other video for us to watch. What's happening here?
This is just sort of an older installation work of mine. I think it hits upon this sort of unique point in history that we're in, where a lot of how we work with traditional mediums and how we engage in music and food, how that's being shifted and transmuted by these different technological systems. So this is an installation project that I did a few years ago, which combines sort of handmade paper craft with computational graphics to create an environment that's sort of this union of both.
So it is a genuine collaborative process.
It's a hybrid process. Yeah.
Hybrid. Let's take a look. So the idea that it's a hybrid process, it seemed like maybe you were hedging on whether it was a genuine collaboration yet. Is that the goal?
I think that's definitely the goal for me. I'd like to see more people engage with, the machine learning behaviors as part of a process that they adopt into their own work. I think we're always inching closer and closer towards true collaboration, even with human actors. So there's a real area to be explored there.
All right, so what do you got over there?
Okay, so what I have here is a demonstration of a very common type of model in machine learning, where there's given a series of notes. It looks for structure within those notes and tries to keep on continuing and predicting what would I play next if I was the one that had played those notes. And so there's a lot of different ways that you can use that within a creative process. And so we've taken tens of thousands of popular songs and just the notes from the songs. So it's called MIDI data, but we train these models to find the structure there and then to be able to generate new sounds when conditioned on, when listening to what it is that someone's playing. So if the sound works out here, just to keep me at all centered, I'm going to put a metronome on. But I could do something where I might have a melody that I'm going to play into, and you'll hear the electric piano will be me, and then I'm going to hear a response from the algorithm running on my computer here that will be trying to continue what I'm playing, and it'll be a cello. So I might go something simple. Respond. So there's some continuity there with what I played before. I have it looping actually, but you can hear the response over and over again. You can hear some similarity to what I played, but it's not doing the job of trying to replicate what I played. It's trying to continue it in a meaningful way.
It's done a little inversion of some of the
a little inversion, but you see it's sort of keeping to the same key and stuff. So if I then wanted to go and play chords behind it, and sort of say, oh, that sounds really good as a melody for my song, maybe I could build off that and be like. Or something like that, and all of a sudden I got the start of course, a very popular hit song. But that's just sort of one type of way that you can be using these tools.
Well, and another type of way is the sounds themselves, right? I mean, we know what instruments sound like,
right?
Because we've made all of them,
right?
But there are potentially a gazillion other sounds out there.
So we take a whole bunch of individual instruments. And we have it learn the structure between all those different instruments, and then provide that as a tool to a musician so that you can interpolate between different instruments and create sounds that are sort of novel and new. So it's a similar idea, but applied now to timbre and texture. So like in this example, we could take the sound originally of a flute. Sounds like a flute. And so here's the model's best attempt to replicate that sound. And you notice it sounds more or less like a flute, but it messes up in some ways, that there's this upper high frequency content stuff, but it's actually, like I was saying, those are kind of mistakes that we enjoy, that it's sort of like you're running back in the old days, the 60s, people would run their turn up their tube amplifiers and get this upper harmonic distortion, and so it's sort of it's natural type of distortion. But you could take on the other side, for novelty's sake. Let's take a cat. So. My wife loves cats, so she was like, you have to do a cat, you have to do a cat. So here's the model that was only trained on instruments like guitars and flutes. This is its best attempt to recreate a cat. It sort of sounds like a cat, but it's like if a cat was played by things. So if you take the flute and the cat, if you were just to add the numbers corresponding to those waves together, it would just sound like the cat and the flute in the same room. There's two separate sound sources. But instead, if we take those core components that the network learns and we mix those core components together, then we get something that's a new sound that combines elements of the two sounds together. So it sort of sounds like a flute that meows. And I can then turn that into an instrument that I can play, and of course, it's very fun and novelty and all good. But we also want to encourage more than just novelty, the creation of new, not serious, but personal expression. So we've also created these tools and integrated them into modern musical workflows as well.
Lab, similar to,
Yeah,
is there
so
anything similar to that in?
Yeah, so once you have these components, you can start playing around with them even in other domains like, say, culinary. Right? You can say, I want Asian-flavored ceviche using dairy products, right? So, and you'll have an algorithm that'll generate something that's pretty flavorful and pretty good. So you can set up, and once, I think this is probably true for you, Jesse, as well. Once you start using these things, you kind of get a sense for what input parameters are good as well. So you learn how the tool works, and you can make it do better things.
Yeah.
And I think actually building the computational creativity system gives you some insight into that.
A great example is this was built with a data set that we created and released to the open public. It was built off sample libraries, and the data set was really biased to like trumpets and synthesizers and stuff. So it sort of makes, like when I play a piano through it, it doesn't get it just right, and it kind of makes it sound more like of a trumpet. And so there's this, even in the training of a model, there's creative inputs in terms of what is the data that you want it to represent, and these types of things.
So Suwen, let's talk about the visual arts. There's got to be an analogy to be made there.
Well, yeah, I was actually thinking about what's fascinating about Lav and Jesse's work, and I think it's that it takes place in the site of ambiguity. Like we know that when we train these sort of new models of thinking to do things that we already understand, it's kind of boring, but when it's to invent a new recipe or if it's to invent a new sound, it becomes a lot more compelling. And
you found the cat flute compelling?
I mean, well, that's the thing. And it's ambiguous and it's novel, but I think there are ways to create our own new narratives using these tools. Like instead of a cat and a flute, I could have a recording of my father's voice and my favorite song, the melody. So suddenly I could hybridize those things, and it becomes a very meaningful way of engaging with each other and like this historical past. And I think while there's a lot of novelty, like I like a cat flute. I would love to play a cat flute. But there's so many.
I knew you did. I knew you would.
But there's so many different ways we can use these core components to create beautiful new interpretations that help us understand these sort of aspects of our histories a little bit more.
Is there a way that these machines that this kind of access that creativity has to those ambiguous places, is that something that you're all working towards?
If we develop these tools farther, and even if they start acting like you can treat it more like a garden, rather than painting like the individual strokes on a canvas, where you're controlling it in the sense that you put a certain amount of water on a plant, and you choose what you plant and how much fertilizer to give it, or maybe you're really compulsive and you do like bonsai, cutting of all the leaves and stuff. But your control is more high level, and part of the interesting part is letting the system do whatever it is that it's going to do. And you understand the system. You go out each day to your garden and you interact with it as the things grow. So I sort of think of like AI gardens in that same sense. That these there's various elements that you want control over, and there's various elements that you don't.
And another thing that these computational creativity algorithms give you is a sense of safety in a way. So you can explore parts of the creative space that you might be afraid of a little bit, because you have this kind of algorithmic guarantee that it'll work out. It's a little bit like GPS, right? It allows you to explore parts of the physical world, and you know you can get home. So that's another thing that really helps me when I use these creative technologies. It pushes me a little bit outside of my normal boxes and puts me in different boxes, but they're kind of somewhere else, and I know it'll work out.
Actually, I have a remark about that. I feel the exact opposite about that. As I think about collaborating with, in a very performative way, this robotic arm, whether it's trained on my own style, which Generation 2 is, or it's just sort of mimicking my movements, there's a real randomness and sort of sense of unpredictability to it, and a lack of understanding involved that is kind of exhilarating and exciting, but it's not safe. It doesn't feel safe or comforting at all. It's like staring into the void.
Well, and even among humans, the phenomenon of apophenia, where you have two disparate, unrelated bits of stimulus, the brain will try and make some connections where maybe there was no intention to begin with. But a lot of artists, Peter, make a lot of hay with that.
Sure. And central to our kind of creativity is taking known components and constructing new things from them. So I can say to you, for example, imagine an egg with wings that's flying around the Statue of Liberty holding an ice cream cone instead of a torch. And you can do that. I could have just said anything, right? And so these mental operations seem to take place in this aspect of our consciousness that is this internal virtual reality that we might call imagination. So consciousness has this sort of dual role, telling us about the world and our bodies in it, but also this internal virtual reality. And this is really central to what we do. And in order to do that, I think we have to have experience in the real world with real things. Actually, in some of my work, we've looked at the mental operations used in, for example, rotating a physical object this way or this way. And then we could decode if someone is imagining rotating it this way or this way, probably because some similar brain circuits are involved in actually imagining it in your internal virtual reality, what you learned in the real world.
There's a program in France, actually it's Sony France, maybe, Jesse, you've heard this, where they fed every Beatles song into this computer so that the computer could learn how the Beatles wrote songs. And then they asked the computer to generate its own Beatles-like songs. And, they had human lyricists.
And Daddy's got a sound so good, like something new. It turns me on. Good day, sunshine in the backseat. God, I wish that road could never stop. Down on the ground, the rainbow led me to the sun.
If you grew up on the Beatles, it's just like, all right, that's kind of cute. If you didn't grow up on the Beatles, though, I don't know what your response to your response might be, oh my God, I've never heard anything like this. This is brilliant. So the idea, you're absolutely right. I mean, it takes a conscious receptor to decide whether something, and so this gets us into the whole question of aesthetics and taste, whether something is in fact creative or not.
Whether something is creative in the good sense, going to be a human consciousness that says, oh, that tastes good, actually. And if my algorithm says, well, this should taste good, and I say, actually, no.
Tastes like garbage.
Who wins? I think it comes down to my conscious experience, and computers, at least as currently configured, are not conscious. Our creativity is very much rooted in our own conscious experience of a world. And so, based on my own conscious experience of the world, I form mental models. So I know what it means for you to feel pain because I've felt pain. And we're constantly modeling things that are actually not in the input. I'm modeling what's going on in your mind, based on what's going on in my mind. That's not visible. And so a lot of our creativity is rooted in our mental models, which are in turn rooted in our consciousness. And so I'll voice a note of skepticism, because in the absence of mental models that are rooted in conscious experience, robots and AI systems, I think, will at best approach as if creativity.
But then
I actually think that's one realm in which the arena of competitive games gets a lot of traction in machine learning. It's because there is a set of constraints. There is a winner and a loser and styles. So in that way, it creates a platform around discussion that's a little bit more stable than a conversation about aesthetics. Do you feel like the realm of competitive games and creating these models that could be conscious, do you think that's the right approach, or do you still think it's quite
when IBM
limited?
created Deep Blue, it could beat Kasparov, but it was doing a brute force search through zillions of possibilities, whereas Kasparov would instantly see a pattern. So our brain is doing something very different, and it could beat him, just like an airplane can fly faster than a bird, but it's doing something very different from a bird, and in this case, the human brain.
So I want to take just for fun, the contrary point of view on this, because so a lot, like you use the Kasparov example, right? And there's recently been these great successes of this AlphaGo program at beating the world champions in Go, right?
in Go, yeah.
And the way that they do it is not through brute force search, right? Because that's it's just computationally intractable, because the game of Go is much more complex. But they do it through the creation of these functions to represent sort of intuition, to represent like roughly how good do I feel this move is. And I can't tell you exactly why I feel it's good, but I have this function that I've been learning that says, like, if these pieces are here and these pieces are here, then moving here is a good move. And it's because I've played a whole bunch of games, and I usually win when I put my piece here, when all those pieces are in those places. And similarly, a lot of the really cutting-edge machine learning and reinforcement learning algorithms explicitly have modeling of, there's some numbers present that are saying, like, okay, this is my representation of the environment around me. This is my representation of what this other actor is doing. This is my representation of what I am doing as an actor in this system. So the concept that, like, our creative critique or analysis is somehow like fundamentally a human thing or requires consciousness, I just find it to be a little bit of a small definition, because here it's very easy to imagine agents that can do things similar in nature to what we might consider to be consciousness, but it's not human consciousness. It's just sort of a broader definition of how a thing interacts with its environment. So you could have a computer critic and computer artists that make art that's optimized for what a computer likes, but it's not necessarily optimized for what we want, and it doesn't. It's just because it's a possibility doesn't mean. I mean, I think we're always going to lend towards creating systems that we enjoy interacting with and that benefit us as a society and benefit us in our own expression.
Does it seem like there are limits? And Peter, you should weigh in on this as well, to human creativity, and is there a limit to what artificial creativity might be?
Yeah, so you can figure out what's the maximum speed a bird can fly through a forest without crashing. So right now the bird is going pretty slow. He can navigate sufficiently quickly that he can avoid all the obstacles and land on the tree. But if he tries to go too fast, he'll crash into the tree, which I think happens in the video. And that's exactly the fundamental speed limit of flight through forests, right? And there's a similar fundamental speed limit for communication. And and what we've been trying to find, and what we seem to be finding, is there's a fundamental speed limit to creativity as well. There's this fundamental tension. You can't be too novel in a given domain, and you can't be too high quality in a domain. There's a tension between the two. So it's easy to be very novel and low quality. You just put random stuff together. It's very easy to be high quality and low novelty. You just look it up in your favorite cookbook or wherever it is. But doing both simultaneously is very difficult, and that's where the limit is. And the larger the inspiration set, the known stuff, the harder it is to be creative. So if there are people in the audience who want to be creative, you should start a new field where there's much more low-hanging fruit, actually.
Are there limits, do you think, to human creativity, as Lav is suggesting there are to computational creativity?
I don't know. I mean, humans have proven to be incredibly creative, both in the good sense of making, airplanes for flight or for murder. And I think of our human imagination as the greatest tool, and also the greatest weapon we have, because we can imagine the most amazing things, and also the most horrible things. And like the Holocaust, that was an act of imagination, actually. And my hope is that these tools will eventually foster human flourishing and not be used to, also create new ways of murdering people. And I think one question I would have for everybody is, what is the goal of all of this? Is it just simply to make new artifacts? Or is it, when I was a kid, there was the Jetsons, and they had this robot, and you would say, robot, do the dishes, and, it would do the dishes. But is it to make a general purpose intelligence that would effectively be a slave? Right? And my guess is that in order to make a general purpose robot like the Jetsons robot, it would have to be conscious. So it would understand what I mean when I say change the tires. I have to have a whole model of cars and everything. But if it's conscious, then we have the problem of slavery again, because it would suffer.
So consciousness implies self-awareness, awareness of self as opposed to an other or others.
The having of experience, like pain, like seeing.
Could a robot be conscious without feeling pain?
I suppose. I mean, there are actually humans who don't feel pain and yet can see, so, yeah.
Right.
Sociopaths.
Yeah, emotional pain, right.
Jesse, what about,
at your end of things?
I mean, I think maybe another way of thinking about it, rather than just, it's really nice to reflect it back on our own human experience. As we've developed tools to better control mechanical systems, we really began to better understand how our bodies work. But what's amazing about these new systems is they do a math that's not human, but it's similar in a way that can help us provide introspection in terms of what are my mental processes? When I'm being self-critical, what are the dynamics of that? How can I interrupt that process, and how does that affect my creative output? And these types of things. You can get introspection in a quantitative way that can help give you words, because whenever you talk, I live in the Bay Area. Whenever I talk about this, I just sound like a hippie. But but it's nice to have things that you can point to say hey, look, this is actual physical systems here. There's something here that cuts common across human experience that we can have a vocabulary to talk about.
I think to that point too, it's important to ask why we're having this conversation now. And I think part of that, if I can flip that script a little bit, is we're generating all this data that's being collected that's very, very difficult to wrap our brains around. And these mental models help us understand the sort of complexity and the scale of our own behavior as a collective world. And I think that's another goal, potentially, of continuing to research these new areas of cognition.
So let me ask you to make one more trip over to the table there. And you gave us a demonstration before of some of the elemental, the basic gestures that this machine, that this system is capable of. What if you try to do something more complex?
Okay, yeah. So I think what I had here to show was sort of more in the concept of creating tools that actual musicians can use to explore. So we had that novelty sound of the cat flute,
right,
for example. And so what I've done here on my computer is to create we want to get this out in the hands of artists and musicians, and to close the feedback loop, because creativity takes two to tango, right? There's the tool with the person, and so we want to get that feedback loop closed. So we created a plugin for this popular software called Ableton Live that if you've ever gone to see any electronic music, most likely it was made with Ableton Live. So here what we can do is instead of just interpolating between two instruments, we can create an entire grid of instruments and allow a musician to sort of take a sort of random walk, take a walk through this space and explore a whole variety of sounds. So what I can do is I can, rather than just play this with my hand, I'll just sort of play a clip here. So right now the instrument is like an organ sound. And oh yeah, you can see this is the software that we have going. But you see this, we've created a manifold for people to play on where we can actually just drag through the space and see the evolution of the sound as it goes between different instruments. And some of the spots, all of a sudden we're like in a dubstep thing, but let's see the spots where it's in between the different sounds, and it creates a whole bunch of different textures that, like, all right, that might be the start to my next track, or something like that, and gives you an ability to interact in this space, right? That you, if you were trying to design by hand to be able to draw through those things, it would be very difficult to do. That's sort of one of those things.
And Sugwen, where do you see computational creativity headed in the visual arts? Are there sort of analogous tools available to you?
Yeah, definitely. There's a lot of like style transfer and this sort of visual assists. Style transfer is sort of the neural networks reading the visual pixel data, essentially, of an image, a popular painting, for instance, and then extracting that style, like Starry Night or what have you, and then transferring that into your next selfie or a picture of your dog or something. So there's yeah, it's compelling. And so I think there's that as a very common approach to using these systems in the visual arts now. What I get really excited about is ways in which we can create new forms of collaboration through sort of processes that we're training these neural nets on.
What about the visual arts as performative arts? Where it's just, normally we only see the sausage. We don't see the grinding and all that.
Yeah.
But it seems like with what you're doing, you want us to see some of the process.
Very much so. I think for me, the creative process is much more important than the outcome, and that's what drawing as a collaboration. That's why it is drawing and not dance or not. I think music performance is a little bit more ambiguous, but actually being able to explore the drawn mark in a way that isn't representational could be a reflection of consciousness or sort of exploratory intentionality, and doing that alongside I hesitate to say artificial intelligence, but machine learning system approaches an understanding of, or at least could create a data set that could help us approach an understanding of what the sort of exploratory creative process.
Well, Jesse, the music throughout history really has had a kind of ambivalent reaction to new technologies. Oh my God, digital music, all the musicians will be put out of work. Oh my God, pianos, all the harpsichordists will be put out of work. And yet we still have real musicians, we still have harpsichordists even.
That's true.
So, the idea that there's room for a whole new kind of generation of creative artists in this field it's kind of a new idea, but it seems like it has analogies to things that have gone before.
Right. In some ways, it's a very old idea. That's where I was sort of going, that this is kind of just part of a long co-evolution that's existed between technology and like music in this case. I think it really just takes a generation that really owns it, that they don't feel attached particularly to the thing that came before, because they weren't alive when that was really happening. So why should they feel attached to it? And some are traditionalists. I play jazz, right? But I also like pushing it in new directions, and so I think that will always happen. There will always be people that find strength in the continuity of learning that harpsichord from the 1600s, and those types of things.
You mentioned the word ownership, and it gets us to something I said before that I wanted to come back to, and that is agency. So Lav, you help create, and your team helps to create this entity that comes up with new fashion ideas, new food recipes, new metal alloys. Who owns that?
So the current understanding of U.S. trademark and copyright and patent law is that it goes into the public domain, because there has to be a human inventor to claim ownership. Machines don't have property rights, at least currently. And so that's the difficulty. It creates this perverse incentive for people to pretend like they were very fundamentally involved in the creative process. But it also raises the natural question, how should we think about property rights in this area? And it's actually important, because who will fund the computational creativity research if you can't actually patent using those tools eventually? So there's no backwards flow of incentives, essentially. So the nice thing with, say, pencils is they're considered research tools. So it's not the inventor of the pencil that gets property rights on things that are invented using pencils. But when you do invent using a pencil, you can claim property rights on that, right? And so similarly, we need some incentives, perhaps a revision of this understanding to encourage development of new computational creativity technologies.
So I think we'll also need wisdom in handling these tools, because any tool can be a two-edged sword, right? A hammer can be used to murder somebody or build a house, and even an atom bomb could deflect an asteroid, right? But these tools are so powerful that they can kind of take on a life of their own, and that, I think, is the danger. And I think there's an example of that in everybody's pocket, right? These cell phones are amazing, right? You have all the information available in the universe with Wikipedia right there. But it becomes very distracting, and many people. I was walking across the Dartmouth Green, and the sky was on fire with the red sunset, and 100 people were doing this, and I almost wanted to say, "People, look at this," but I didn't have the courage to do it. And I noted that, in my mind, that 30 years ago, walking across that Dartmouth Green, I would see 10 people holding hands, and I don't see that hardly anymore. And these devices meant to foster human connectivity have in many ways undermined it, because people are more distracted, less attentive, here instead of talking to people, like when I was a kid. And AI is very powerful, but it runs the same risk. We have to own it. We have to become agentic ourselves and make sure it serves our ends, creative or otherwise, and that we don't become slaves to it.
But if AI does reach a point, Jesse, Sue Gwen, where it can compose a piece of music, create a genuine work of visual art, something that moves us, that genuinely passes the Turing test, that, we know where it came from and it uplifts us anyway.
And you don't care.
then does that AI entity have some sort of agency, some sort of ownership, as opposed to the humans who set it in motion maybe a generation earlier?
I mean,
I know we're into William Gibson territory now.
No. I mean,
science fiction.
It's all good stuff, but I think like grounding in what you were saying about like cell phones and stuff. Like, it's really fun to think about these scenarios where you start thinking about personification and constant evolution and stuff. But the fact of the matter is, for the technology to ever reach that point, we'll have gone through so many transformative things in our society that are like, there's lower hanging fruit than that will change everything. And so I always think, and like there's lots of groups like Google, OpenAI, DeepMind that are really focused on more of the short-term things of like, like how does this affect our society here and now? And if we ever reach that point, the only way we'll ever do that is if we figured out all the stuff that comes before it, because otherwise, it just won't happen.
But can I add
agree with
that
that.
in order to get to that point, we'll have to have deep mental models of what it means to be a human being, rooted in what we have experienced as being in human beings, right? So, for example, you know that scene in Les Mis where Jean Valjean has been in prison for 19 years and he hates the system and he's angry, and he stays with this priest who, he then steals the silverware of the priest. And the police catch him and bring him in. And then the priest, in an act of true Christian grace, says to him, release him. He didn't steal it. I gave it to him. And here, you forgot the platter. And we find that deeply moving and beautiful because we can understand having hit bottom. And then by having hit bottom, he goes through a mental transformation and he realizes, I'm not this. I need to become a new kind of person. That can only be understood by us because we have human experience. And I'm skeptical that AI is going to be able to understand, redemption like that. But maybe, but again, if we get to that point, they will be humans or very close to us.
So Gwen? I know, that's a tough act to follow there.
I think part of how we even categorize what makes us human is how we create our own narratives. Like you explained sort of this sort of profoundly human moment through the narrative of Les Mis. I think right now we're in the process of creating narratives around machine learning. We're calling it artificial intelligence. We're calling it designed intelligence. This is definitely an interesting precursor to that question of agency. Mm-hmm. We form our own through creating narratives, and now we're able to co-create narratives with these machines. So I think that's sort of the path forward.
Well, and the arc of human history has been to acknowledge agency for more and more people. Agency was for many generations restricted to a certain gender and a certain group of people, and we hope that is a continually expanding definition of agency, and whether it can include things that are artificial, I guess that's a question that will be answered down the road.